Hi math lovers! Today I have some more mixture problems for us to work on. So the first one says, how many grams of water must be added to 120 grams of a 30% iodine solution in order to produce a 20% iodine solution? Okay, so I'm a chart person. I like to set these up as start, add, get problems. And so you're going to start with your amount that you have. You've got your percentage, and then your total. And when we talk about the total, we're talking about the total iodine here. So go ahead and think of this last column as your total amount of iodine, okay? So the amount that you're starting with, well, it says how much must be added to 120 grams. So I'm starting with 120 of a 30% iodine solution, so that's 0.3, in order to produce 20%. So I'm going to get a 20% solution in the end. And let's see, I don't know how much I'm adding. That's my unknown. My final amount would be the sum of these two, so 120 plus X. And what percent iodine is in water? Stop and think about it. Right, 0. Okay. So we're going to go across just like we did yesterday, and we're going to multiply. So 120 here, 120 times 0.3, 0x, and then 0.2 times 120 plus x. All right, so our final equation, when we're going ahead and solve it, is going to be this plus this plus this. So it's how much we're starting with, how much we're adding. We're going to add those together. So we would have the 0.3 times 120 plus 0x. I'm going to put it in there just as a model. You know, I always like to follow the step-by-step, kind of old school like that. Okay, so now I have 0.3 times 120, which will be 36, plus 0. And I'm go ahead and I distribute. So I've got 0.2 times 120, that's 24, plus 0.2x. We're going to go ahead and get our x's together, our 1x. We'll bring the 24 over, so I have 12 is equal to 0.2x. So x is equal to 60, and we're talking about grams, so 60 grams. Does that make sense? Should I add, if I take 120 and I add 60 grams, I'm going to get a solution that has 100, the amount is 180 grams, and I'm going to get 20%. All right, cool. All right, so we set that whole thing up. I'm going to go through and talk about how we set up these other problems with you, and I'm going to leave it for you to solve, okay? So our second one, we're going to have our start, we have our add, we have our get. Right away, I'm going to set them up amount, percent, and then our total. Okay, so right away I'm going to set up my chart. It says a nurse wishes to obtain 800 milligrams of a 7% solution of boric acid. So 800 milligrams, or I'm sorry, milliliters, mess up my metrics, 0.7, by mixing a 4% solution, so 0.04, and 12% solution. Okay, how much of each should the nurse use? All right, so we don't know how much she's starting with, right? So let's call that X. Now, how much is our amount? Now, I know you're thinking, hey, let's put it in a Y, but you're not going to do that. We're solving with one variable. So I've got I'm going to have a total solution of 800, and I already have X. So that's 800 minus X. We go ahead and we multiply to set this up. So 0.04X, 0.12 times 800 minus X, and then 0.07 times 800. I'm going to leave it for you to set up the equation. Go ahead and solve the problem. Okay? Let's go to the next one. Oh, this is the antifreeze question. This is a good one. We love antifreeze. All right, again, we're going to have a start. I'm going to write the word start just to hammer it home. Add, and then get. We have our amount, our percent, and our total. Haven't even started the problem, and I know it's going to be a mixture set. All right, how much pure antifreeze? Pure antifreeze. That's the key word here, pure. I know like juicy juice, you have juicy juice, it's 100% juice, right? Pure antifreeze would be just like 100% juicy juice. It would be 100% antifreeze, okay? Must be added to 12 milliliters of a 40%, okay, so 0.4 and 12, solution of antifreeze to obtain a 60% solution. Okay, So we don't know how much we're adding. So this will be 12 plus x. And pure antifreeze, that's 100%. Okay. I'm going to leave you to set up the rest of the problem there. And one last one, I think this is my favorite one of the whole problem set today. Okay. It says how much water must be evaporated. Oh, evaporated. We're going to set this up a little bit differently. So let's see. Instead of doing a start, add, get question, right? I'm not going to add. What am I going to do? I'm going to subtract. Oh, fun. That's why we're in honors, because we love those little twists. How much water must be evaporated from a 300-liter tank of 2% salt solution? So 300 liters of 2% to obtain a 5%, so 0.05. So do we know how much we're going to evaporate? No, that's our unknown. So we're going to have 300 minus x, right? That's how much we're going to take away. Now I'm talking about water. How much salt is in water? Okay, same thing up here, like we did up here with the iodine solution, it's 0. And you multiply across to get your answer, okay? So you go ahead and do 300 times 0.02, 0, and then 0.05, and then 300 minus x. We'll go ahead and multiply. To set up that equation, you're going to take whatever you're starting with, and you're going to take it away, right? So it would be 6 minus 0 is equal to, and we're going to distribute here, this would be 15 minus 0.05x, okay? And I'm going to leave that for you to solve. Okay, this is day 2 of the problem set, so you're probably really good with your mixture problems at this part. I just want to make sure you're good with setting up your start, add, get. As soon as you see it's a mixture, jump right to it, start, add, get. Have fun with your problem set.